All right, I want to walk through the protocols for creating a polygon fishnet. That'll be the first thing in regards to typing out burn areas that we're going to find on these different images, these randomly selected images. So here's our area in Flint Hills. This is our area of interest. Initially, I created a polyline fishnet, and this fishnet in particular, it basically coincided with the 250 meter cell resolution of the burn area product developed by Kansas DNR. So it's a one-to-one correspondence, and we'll be using the parameters that were set on this polyline for creating the polygon coverage, which will be a fishnet polygon. And so in creating a polygon, there's certain parameters that go into that process, and I'm going to look at that just briefly. So we have naming conventions that I'll discuss here in a little bit, but you describe the naming conventions where you're going to place the polygon coverage. And then you're going to put in your upper left and lower right coordinates, and those will coincide with what the original dimensions were for the Kansas product. So it'll definitely align with that. You've got your fishnet origin. That'll be your lower left corner, and your y-axis coordinate, which basically orients the entire fishnet itself. And so it'll take the origin x coordinate, and it will go in the direction that you deem towards the upper limits of what the y coordinate could be. Anything on that y-axis. So width or height are explanatory. Rows and columns, those are easy to figure out. I'll show you on a different Word document. And you don't need to really put the opposite corner. You can if you wanted the X, Y. I don't like to create these label points. They just get in the way. Go polygon, and you're good to go. So let's go ahead and turn this polyline off and navigate to our image. And so in picking a point in the upper left, you want to be far enough to the left and far enough high enough that it covers the entire area in a square image or rectangular image. The lower right in the same way, so I'm going to pick it down in this area, lower left somewhere up in this area, so it makes sure that it covers that left corner. And so when you do that, you need to make sure that you zoom in, you get to go ahead and get the coordinates, and then you apply the appropriate last 3 digits to the and plus the decimal points. The numerator numbers beyond the decimal have to align every 250 meters. And what I mean by this is that this is the upper left and lower right of the original fishnet, which coincides with the Kansas DNR product. And so the x coordinate has to be multiples of 250 beyond this 446.79. So whatever you write down, it's not going to exactly match a 0.79 or maybe a 6 on the end, but it's going to be very close. So this multiples of 250, you can just figure out very easily by taking that 446.79 and adding 250 to each iteration. So 250 plus that gives me 696.79, 250 plus that, 946.79, and so on. So these 4 are only options for the endings of whatever corner we're looking at. The y component, similar way, you've got this ending right here of 232.335, and so that's got to have multiples of 250, so 232.335 plus 250 plus 250 plus 250, this is how it plays out. And so we go ahead and we've got our TIFF image, and we chose our upper left, and basically adjusting it according to the closest number. These are the upper left and lower right coordinates for the Fishnet polygon that I'll be working with. One of the other things that is needed is the number of rows and columns, and that's simply by taking the dimensions of the x-axis, take the larger minus the smaller, divided by 250, gives me 164 columns. Rows is basically on the y-axis, so 417 blah 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 minus 414 divided by 250 gives me 118. So other than that, you're good to go. You go ahead and apply those. The naming conventions, let's see if I've got the naming conventions back on here. What did I name it? Where did it go? Naming conventions. Should have been ready for this. Oh, here it is right here. So basically created this polygon coverage, polygon underscore fishnet, the date of the image, and then there is a unique identifier that's within the TIFF image of 171458, which you can see right here. This 171, oh, that's 545. There's 548 is the one I used. This is the this is it down here, the 458. So we go ahead and name it, and then apply the coordinates for the fishnet, and then the fishnet origin coordinate, which, as I mentioned, is that lower left coordinate. That's there. The y-axis coordinate is going to hold. It's always going to have the same x that we have above at the fishnet coordinate, but it's going to give us our orientation. So we just moved up 10 meters from 982 to 992. It gives us the directionality. So that works there. 250, 250. Rows and columns are in. Again, click off that label point, and then you are set to run that. So we ran it, and you get a polygon coverage like this. And so the process now of looking at this, so we got this polygon fishnet that is perfectly aligned, and it's time to start mapping out and selecting the pixels that are deemed burned and assigning them those values. And so I think easiest way to do it, I've already pre-selected these. So you just go ahead with a selection attribute and just click on each of these. Actually, I can just show you as we go. So selection will clear it, and then select features. You'll push shift down so you can hold it down. Select all these that are greater than 50% burned and within each of these pixels. I'm not going to choose that pixel because it has a lake in it. Takes up most of the area. So once we get that, we go ahead and extract that by data export, and the selected features, yes, we have a name for it, and the name I selected was poly burn area select. That's just in a temp folder. So what happens is we get the selection, and we still have these internal framing of the pixels themselves, and they have to leave, so we just do a dissolve. And by doing a dissolve, it brings up everything is removed from inside. We also want to know what the area is, and so there's a way in which you can do area, add area, let's say add area. And you can add geometry to your data. And so, I'll bring that up and to the dissolve area. Unit length is meters. Area unit, hectares is what we want. And coordinate system you can put in there too. The one I've been using is this guy. And there you go. Then what you do is you go ahead and run it. I've already run it. And it will put in a new field for that area. You're not going to see it initially once you run it. You've got to remove the polygon and then bring it back in. And once it's brought back in, it'll show the area measurement of 100. And so basically you're going to run through the entire image, selecting those that are burn pixels, and then moving on from there. And so I'll go into more detail as far as what looks like a burn and what's not, and also some other things to keep in mind when we're going through this. So that is it.